The scatter diagram shows the ages in years and the selling prices in thousands of dollars of second-hand cars of the same model. That's important because it gives us a point of comparison. The cars have been advertised for sale in a local paper. So here's the scatter graph, and you can see just at the bottom here, the first question, how many cars are being advertised for sale? And that's just a case of counting the crosses on the diagram. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 cars advertised for sale here. One car has been advertised incorrectly. Which one is it? Well, I think the one that we are supposed to go for is this one here that seems to not fit with the general trend of the others. So that's the one we would go for. It's the obvious answer in year 10. However, there are factors that could make this absolutely a genuine point and the car actually be worth that at that age. Draw a line of best fit and use the mean point. So, I wrote down the coordinates of all the points here. You would need to find them. I've got 1, 8.6, which is this point just here. Then I've got 2, 7.8. 2, 6.6. 3, 6.4. 4, 4.6. 5, 4.8. 6, 3. 6, 4. 6, 7.2. 7, 3. And 8, 2.6. Now note the 6, 7.2, that was the point that we identified as not fitting. It may be in some circumstances that you need to remove that one from your calculation of the line of best fit. But for now, we're just going to leave it in. Now, how do we calculate the mean? Well, we add up all the x's, so 1 plus 2 plus 2 plus 3 plus 4 and so on, and divide by 11 because there's 11 pieces of data. If we do this for both the x and the y coordinates, and you can check that you get the same result, to 2 decimal places I got 4.55 and 5.33. The orange point that I just put onto the diagram is that point. Now we want to get a line of best fit through there. So what we're going to do is get our ruler, make sure that it goes through the orange point and it fits the data as well as possible, which means trying to get it roughly evenly balanced with the number of points on either side, or at least their distances on either side. I think the line that I added here is not too bad. Remember, this point here is quite a long way away. If we discounted that point, then maybe my line, well, it would be different because I computed the mean point using that point as well. So the whole line would move a bit. But I think looking at it, it's reasonably through the data. So, what do we ask to do next? Use the graph to give the approximate age of a car that is advertised for $4,000. So we use our line of best fit here. We'll go to $4,000 and we will go across to the line of best fit, and then we'll measure downwards, and we can see that that would be around 6 years. So we would say approximately 6 years. Another car is to be included in the advertisement next week. The car is 4 years old. Do you think the price will be more than 6,500 or less? Give a reason for your answer. So let's go back to the graph, and we're talking about something that is 4 years old. So 4 years old, go up and across, and it looks like, so an average price we'd expect to be about 5,800. So they were asking us about 6,500. So I would expect it to be less than that. And just refer to the graph for your reason. Describe the correlation between price and age of cars. Interpret this relationship in terms of the given variables. Those are actually two slightly different questions. So correlation, we can see that as the age goes up, the price goes down. The line of best fit has a negative gradient, and that means we have a negative correlation. Now, in terms of the variables, which are age and price, we might say something like, as the age of the car increases, the price decreases.